So polyatomic ions, you now know how to write names and formulas for a type 1 and a type 2 binary ionic compounds. You know how to write a name for metals that have both one possible charge and more than one possible charge. And the ones that are binary have only 2 elements in the compound. Now we're going to look at the ones that have more than 2 elements in the compounds. Polyatomic compounds. Polyatomic compounds have polyatomic ions in them. Okay, I see a lot of you guys writing, so I'll hold off for a second. Now, polyatomic ions are covalently bonded atoms. They're a group of atoms that are bonded together and have their own formula, their own name, and their own charge. They act like a unit. They act like an anion. I can talk. Anion, all by itself. So you have acetate here. Acetate is C2H3O2 with a -1 charge. Nitrite, I think that's what it says. NO3 with a -1 charge. You have, can't read some of these, phosphate, PO4 with a -3 charge. So they all have their own name, own formula, and own charge. You have to make sure you keep these units together. They act like the anion in this compound. You will find a list of these on the back of your periodic table, and you'll see they look like this. So turn over your periodic table and find them. You do not have to memorize these. If you take AP Chemistry, you have to memorize them all. Here you do not. They're alphabetical: acetate, amide, ammonium, bicarbonate. So you'll kind of have to just familiarize yourself with this group. All the different, all these different polyatomic ions and where they're located. Now, they're all anions. An anion has what charge? Negative charge. They all have negative charges except for 2. Ammonium is one of the only cations we have as a polyatomic. And down the road, you're just going to have to memorize NH4 is a polyatomic. That's it. And then we have hydronium. We won't use hydronium. We use this with acids and stuff. So you'll never use this in names, but you will use the ammonium in the name. Okay? But almost all of them are anions. They'll take the second part of the compound. Does that make sense? Yes? We good so far? Okay. Now, let's learn about these things. So, I'll put this over here. Pull this guy up. Let's learn polyatomic compounds. Put it way over here so we can, let me ask if I can get this over here a little bit so I can push this a little farther this way. There you go. Okay, so polyatomic compounds. So you have your flow chart, correct? Well, let's write formulas first. Formulas are usually easier than the names, so let's do formulas first. Okay, so if I have, oops. So let's look at this. So if I have the name sodium bicarbonate. Okay? So the first thing you do is look up the symbols. What's sodium symbol? Na. Na. What's sodium's charge? Look it up on your periodic table. Do not guess. Plus 1. What is bicarbonate's formula? So you're going to have to look on the back of your periodic table. What's its formula? HCO3. And its charge is -1. Now, let's stop here for 1 second. How did I know that was a polyatomic ion? How did I know that's polyatomic? Okay, it has 3 elements. How do you know it's got 3 elements? How, when I said sodium bicarbonate, you went, oh, I need to turn my paper over and look for a polyatomic ion, besides the fact, what? You never heard of it? The 8, thank you. Remember, we were talking before that all binaries end in what? IDE, correct? Sodium chloride, magnesium sulfide, copper 2 iodide. They all end in IDE. This guy ends in ATE. Most polyatomics will end in ATE or ITE. 8 or ITE. There are some IDEs in there. You're just going to have to figure them out. But if you see an 8 or an ITE, that's polyatomic. Okay? So far, so good? Okay, so then I crisscross my numbers here. That 1 comes here. Now I told the other group, if you want to put this polyatomic in parentheses at first just to get used to it, you can. And then there's a 1 down there. So it's NaHCO3. If you want to do that. Does that make a little sense so far? It will. It'll come around. Give me a couple more. Okay?
Do we have to do that?
You do not. If you're comfortable without doing parentheses, then by all means don't do that. Let me do another one here. Oops, squeaky. So if we have copper 1 oxalate. Copper symbol. C, well done. And what is copper's charge? Whoop, no, what's copper's charge? 1, right here. Look up here. It tells you, yeah, that's your +1 right there. Right? Okay? What is oxalate's formula? C2O4. Notice I'm putting it in parentheses. And what's the charge on oxalate? -2. So then this 2 comes down here, and that 1 comes out there. So it's Cu2, C2O4.
Can you simplify it? Or are you
This, you can't change their formulas. The formula of the polyatomic is set. You never touch that. Good question. Does that make sense? Let's do a couple more of these and then we'll go into naming. Okay, so let's do lead 4 sulfate. What's lead symbol? PB. Good job. And what's lead's charge here? +4. Thank you. And what's sulfate's formula? SO4. And what's sulfate's charge? -2. There you go. I'm going to put this in parentheses just to keep things clear. That 4 is going to come down here, and that 2 is going to come over there. Make sense? Yes? So it's PB2 SO4 4. Now you have to make sure you put parentheses out here, because if not, you're going to have 44 oxygens. That's not good. So you want 4 sulfates, not 44 oxygens. Can I reduce this at all? Yes. If I divide this by 2 and that by 2, I get PbSO4 2. So far, so good. Yes? Can we write formulas for these? Now, there's a couple that are a little strange. Let me show you. I forgot to show first block, so I want to make sure I showed it to you. If I have lithium, is there questions? You okay, guys? Okay. Lithium peroxide. What's lithium symbol? Li. Li. And what's the charge on lithium? +1. Remember, charges have to be plus or minus, so make sure you know that, okay? What's peroxides?
O2.
O2. And what charge is on peroxide? -2 or -2. Now when I cross them, the 1 comes over here, and that 2 comes down there. So it becomes Li2O2. A lot of people go, wait a minute, I think you made a mistake, Miss Cottingham, you put the subscript wrong. Before you do that, look at your peroxides. Peroxides only bond with group 1 metals. So this is a 2 here, not because oxygen's a -2 charge, because you have a peroxide. Because if you go backwards, that 1 cannot make a 2 down there, can it? Everyone always thinks I make a mistake, but it's actually a peroxide. Okay? Okay, so let's go to naming now. Naming's the harder part. How do we feel about writing formulas? Writing formulas is pretty easy because you just write down the symbols and the charges and you crisscross them, right? Now, real quick, before I leave the whole formula thing, I had people doing this last block, and I want to make sure this is, you don't do this. So if I have copper 2 hydroxide, I had people still doing this. CuOH -2. And I went, what? Wasn't quite sure what was going on. I don't know why they just brought this 2 over here as a superscript, as a charge. I don't understand it. But if you're thinking that way, make sure you know that means it's a +2 and this is a -1. And they have to come down. That 2 has to go down there and that 1 has to go down there. You have to crisscross them. Does that make sense? Okay? I was just trying to clear up some misconceptions I saw first block. Oops. Okay? Now naming. This is where you're going to use your flow chart. Okay? So if I have AgNO3. So my first question on my flow chart is the first element binary or first element hydrogen? No, it's not. It's not hydrogen. Then I say, okay, is it binary? Is this binary? Nope. It's not binary. If you say no, it's not binary, do this for me. Draw a line after the first element. Write that on your flow chart if you'd like. If it's not binary, cut off that first element. Everything after that line, everything after the first element will be your polyatomic ion. This is your polyatomic ion. What is NO3? Sorry? No, it's a polyatomic ion. So you have to look up the name on the back.
Nitrate.
It's nitrate. NO3 is nitrate. Does Does that make sense? Guys, it's a lot of looking here, looking there, looking here, looking there. If you don't do that, you will not get this. This is not a time to be a little lazy and say, I'm just going to think I know them. I'm still using the periodic table up here. I don't remember all these. So I know you're not going to. Okay? So, nitrate is this part here. And then is this first element. Next question is, does the metal have more than one charge? Does silver have more than one charge? No. So what type of compound is this? Follow your chart down. It's a type 1 polyatomic compound. So you just name it as you see it. Silver nitrate. Does that make sense? Are we okay with this a little bit?
So on the test, will we get this flowchart?
No, you will not. You have to know how to do this. I'm looking at next week, probably before the quarter.
So
But you have to know how to name them, because when we get to writing reactions, it's like a second language. You have to be able just to read and write them. Okay? Now you can use it on quizzes up to that point, but come test time, it has to go away. Okay? So let's look at another one. Let's see. What am I doing? There we go. So, first thing, it's the first element, hydrogen. No. Is this binary? No. Then I'm going to do what? Cut off this first element. What is OH? It's hydroxide. Thank you. It is hydroxide. Does the metal have more than one charge? Is it highlighted on your periodic table? Turn your periodic table over to the other side, Mason. There you go. Find lead. Yes. Lead is a type 2 metal. It's got more than one charge. So you need to do a little investigative work. So, if this is a type 2, you have to check your charges. Hydroxide has a -1 charge, doesn't it? Yes? Does this one match this number down here? Yes. If these two match, then these two have to match. So what's my charge going to be on lead? +2. So this is going to be lead to hydroxide. Does that make sense? Talk to me. We'll do a few more of these. Get used to them. So far, are we okay? Okay. Let's try another one. Please stop the sounds. Okay. Let's do, is the first element hydrogen? Nope. Is this binary? Nope. So what do I do if I say it's not binary? Cut off that first element, right? Cut off that first element. What is SO4? Sulfate. So we write down the name, sulfate. Does the metal have more than one charge? Yes, it does. And because it does, you need to check your charges. Now, the all-important question, what's the charge on sulfate? Negative 2. Does this 2 match that number down here?
No.
No, it does not. Since these two don't match, what do I have to do? What's my charge going to be on a 10? 8. How many guys think it's 8? Well, that's why if you put these in parentheses, it'll make it easier on you. What number is outside these parentheses? That's a 1. So 2 times 1, that's a plus 2 charge up there. Does that make sense? Talk to me. So this is 10, 2 sulfate. These are not simple. You have to do some detective work on them. I see some eyeballs saying, oh my gosh, I do not get this. But ask me the questions. I don't know what part you don't get. And I'm sure everyone else has got really similar questions in their head. What don't you get? You got it? Okay. I'm glad. Good job, Hunter.
Everybody.
I wasn't looking at you, by the way. Ask me some questions, please. Okay, Brett has a question. When?
You write your Roman numerals as just lines. If I do mine as eyes, are you going to take all the points on this?
I will not. No. I know that they're eyes. It takes too much time for me to write lines. But I can live with that. Okay. You want to do another one, or you want to head? Let's do a couple more. Okay. That's why write them down on follow your flow chart and write these things down in your flow chart, what I'm doing. So and also, or follow that thing I gave you, the PowerPoint. Okay, so let's do, let's write it down. You want to try to do it yourself first, and we'll go through it? Do that. Okay, we ready? Okay. Okay, so let's look at this.
A -2 and a 2 won't match up, right?
Yes, they match up. You look at the number, not the charges, but the matchup. Let's walk through this real quick. Okay? So, is the first element hydrogen? No. Is it binary? No. So what are you going to do if it's not binary?
Draw.
Cut off that, draw a line after the first element. Write that on your paper. If it's not binary, draw a line after the first element. Write it on that flow chart I gave you so you know what to do each and every time. After you draw the line, what do you have to do?
And you gotta flip it over and get
No,
the name.
okay, find the name. What is CR207? Dichromate. So write down the polyatomic name. Dichromate. Okay? Then you say, okay, does the metal have more than one charge? No. So if the metal does not have more than one charge, what do? Name it as you see it. This is zinc dichromate. You don't have to do any investigative work at all. Only with the type 2s must you do investigative work. Does that make sense? Maybe under that box with type 2, write down investigative work. Okay?
I was missing, like, as a bond, if I just wrote the charges and crisscrossed them and just divided them by 2.
If you wanted to, but it's yeah.
That wouldn't be anything.
No. Nope. Because I'm just going to ask you the name. That's all I'm going to ask you. Does that make sense? Yes or no? How are we? Do you want to start some practice or you want to do another one? Let's start some practice then. So you're going to practice polyatomic 1 and 2, and then when we finish that, I have a homework sheet for you. Okay?